Hi, now that we have an example for model search, model selection, and how to do it in R. Okay, so library, the ISWR, so this is the library for our textbook, Introduction to Statistics with R. And we use the cyst fiber data set. So this has many variables: age, sex, height, weight, so many demographic information. BMP, the FEV1, RV, total, I don't know, but these variables, and the Y response variable is this. And this represents some lang function, and we want to explain this by these many variables. So we want to have the best set of predictors. Okay, so at first, the fit the full model. The LMF is the P max on all other variables, and then we can get all coefficients. And a typical situation happens here. And okay, so if we see t value, okay, so it's not really close to 0, but anyway, no one is significant. So it sounds like we fit some response on just the random numbers. But just don't panic. This is a usual situation. And why this happens? Because these variables have many kind of relationship, complicated relationship. So if we put everything in the model, so it doesn't, tell us which variable is the most useful. So it's not really hard. It's not really easy to see. And now that we do stepwise selection, the default is the backward selection. You can see the explanation of step function, but if you put the full model, of course R can recognize the smaller model, so we can drop some variable. So the step of some linear model is just the stepwise, the backward selection. So for forward selection, you can imagine that at least we have to specify the largest possible model and also the starting point. Yeah, you can see just the description in the step function to see how to do the forward selection and the both ways selections. Then, so R, drop one variable at a time. So just R tried the several models, 1, 2, 3, 4, 5, 6, 7, 8, 9 models, and the full model itself. And when we drop sex, then actually the prediction, the AIC improves most. Actually, probably those variables are not very important to explain the PE max, because if we remove it, actually the model becomes better. But okay, so at first, this is least useful variable, so we drop this variable. Then next, after we remove this, then we remove one more variable and to see if the AIC gets smaller. So this is intermediate step. So now that we only have the 5 variables remaining, and still if we drop height, it's better than do nothing. So we drop height. And finally, here, if we drop any of the variables, AIC gets worse. So that means that it's better not to drop any variables. So we stop here. Then the final model includes these 4 variables. Okay, so final model is here. Actually, we can just specify final model as step LMF, full model. Then we can, we don't have to type these variables again. So it automatically get the best model. And also, if you type the trace, TRACE is equal to 0, then we can avoid the printing intermediate result, and we can only see the best result, the final result. then this is the model result. So we have 4 variables. And the one good thing is that the standard deviation gets much smaller. And actually, the all t values become significant. Actually, the last one is not significant, but the most variable becomes significant. So it's at least the more interpretable model. So weight has positive coefficient, certainly positive coefficient, and the BMP have the negative coefficient and it's significant, and so on. So the last one is a kind of the marginal case. So it's not significant. It looks better than nothing. So possibly it's useful. So that's why that we include it, even though p-value is not larger than 0.05. So 0.05 is the the number the human created. So the originally, I think the Fisher, they used the p-value of 0.05 because the normal distribution, if we use -2 and 2, so it looks the unusual case, and this probability is approximately 5%, slightly less than 5%, like the 4.7 or 8%. But it's useful. It's convenient to use this 2 when no computers are available. So that's why people are using 2 and 5%. But that is just the human, the criterion the human determined. So not really scientific. So 0.14, okay, so larger than 0.05, but still it's included by AIC criterion.